Hello, everyone, and welcome to Block, File, and Object Storage and Why They Matter to You. This is the first in a series of DataCore educational webinars on object storage. First, let's start with some introductions. My name is Adrian J. Herrera. I'm the one to the right there. I am the product marketing principal for object storage, and I'm going to be acting as the moderator today. And with me, I have our product experts. We'll start with Augie Gonzalez. Augie, why don't you introduce yourself to everyone?
Thanks, Adrian. And I'm out in Fort Lauderdale, Florida, beautiful Fort Lauderdale. Been with DataCore for 12 years, and before that was in the space program, involved with missile assembly and testing and manufacturing. So I've got firsthand experience with all these technologies that we're going to talk about, both as a user and as on the vendor side of it. Eric?
And I'm Eric Day, and product manager for the Swarm object storage component of DataCore's offering. I've been involved with the development and evolution of Swarm for the past 15 years or so. Prior to that, I did a lot of work in the consulting industry around IT management and automation of processes. And so I'm one of the originally one of the core users of technologies like object storage.
And of course, my name is Adrian J. Herrera. I am, again, the product marketing principal for object storage. I come with Eric through the Coringo acquisition to DataCore. Very happy to be here in sunny San Diego. And before DataCore, I worked for some cloud storage companies, both on the enterprise and the consumer side. So I have a very strong storage background. And with that, let's go ahead and talk about what you're going to learn in this webinar. This is what we hope you will learn. You'll learn the differences between block, file, and object architectures and topologies. We're going to spend a lot of time on protocols and how you can access those different architectures and topologies in different ways, how those architectures and protocols affect use cases and workflows, and then finally, how to determine the right architecture and deployment method for your specific requirements. We're going to go over 3 topologies, 3 architectures. There is a time, a place, a workflow, a workload for each one of those, and there are some overlaps between them, and we will discuss them, and also hopefully at the end of the webinar you'll be able to determine the right architecture and deployment method for your requirements. So from a very high level, here are the 3 types of storage architectures. These should not be a surprise since they were in the title of the webinar. But let's go ahead and start with a quick description of what you're seeing here. So you see block, and we start with block, and from a one statement perspective, block is generally meant for high transaction and high rate of change data segments. And we'll go into the reasoning for that in this webinar. File is really about collaboration and portability for frequently changing files. And object is for ease of management and access at scale for static content. I think, Eric, when we were talking the other day, you brought up a really good point from a visual perspective, seeing kind of how data grows from left to right. Do you want to give a quick explanation of what you're talking about there?
Yeah, basically you go from the very granular to you're managing higher and higher levels of abstraction as you move from the left to the right. And so it's really about the sort of unit of storage that you're managing or you're concerned with on this continuum. You know, down at the block level, you're looking at 512 bytes or 4K worth of information at a time. As you move through file, now you're worried about full file objects or full files, and then as you get into object, then you get into again you have the full file, but you may be looking at a version chain of files. So the file may actually represent, or the object may actually represent a continuum of versions, changes that have occurred. And with object, you're looking at whole versions of it and not just something like the current file that's out there. So that was kind of the observation, is how it's you're managing higher levels of abstraction as you move across this scale.
Yeah, and the reason I wanted you to point that out is because this will come out in the information that we're about to cover. So from a visual perspective, I really like the way that you position that, and that's what we tried to represent here visually. And do you have anything to add, Augie, before we jump into block?
Well, we'll talk a little bit more about file in the ensuing slides. I think we'll save it for then.
Right. So let's jump into block storage. So Augie, take it away.
Yeah, block storage is at the ground floor of storage architectures. It's used by as the native disk, basically, that you're familiar with. It, unlike the other two, is seldom in touch with a human. It's always, there's an intermediary that's involved with this, and we'll get into that a little bit more. The orientation of blocks is very fixed. It's very regimented into these block sizes, whether those are 512 byte or 4K bytes. They very much are targeted at low latency, high transaction environments where you have a lot of change in a small segment of the information hierarchy. And there's really no tagging or anything like that. There's no relationship to the origin of this. You're pretty much looking at raw data in its native form carved out into these things. The most common usage for block storage is by the operating system proper or the hypervisors, and it's kind of structured along the lines of a volume, a classical volume. So we as Carbon robots seldom are involved in this. This is all downstream from us, but we benefit from it. And the connections tend to be as simple as the legacy kind of SATA drives that we've seen, the SCSI protocol. FC stands for fiber channel. Fiber channel is on the faster, low latency end of the business, and iSCSI is kind of the dominant way to connect into block storage for storage area networks today. The one that gets a lot of attention these days is NVMe, and that's a multi-channel connection, a lot of parallel paths into storage for high throughput and also low latency. So we'll see how these shape up in the next few conversations.
Yeah, and do you have anything to add there, Eric?
Yeah,
I know you're the object guy, but you have a lot of knowledge about block and file too.
Yeah, I think the interesting observation about what Augie just said was that that we humans, and I hadn't heard the term carbon robots.
Yeah, carbon robot. I was going to ask him to explain carbon robot for those who may not be that familiar with English
Sorry about
that. But for the
humans, right?
But for the humans, I just thought it was an interesting observation that typically we end users don't have a personal relationship. We don't interact directly with block. It's always something else that's deciding on how to organize it. I thought that was think of that as we now walk through file and object.
Yeah, and I want to just have everyone kind of focus on that no metadata and the carbon robot and human aspect of it. Because when we shift into the object world, you're designing user interfaces and applications for humans, where metadata really comes into play. So we'll just kind of capture that mentally. We'll talk about that coming up in the object slides, but I think that's a really good segue, and it's really good. Here, this is all for machines, but metadata becomes very, very important once you start designing applications for humans, and we'll talk about that in a bit. So with that, let's jump into file storage. So Augie, again, you are the file expert. Take it away.
Well, the files are completely the opposite, right? Files are all about how people see the universe of data, how they structure themselves. So this is a carryover from the old cabinets and how do you file things in the drawer. And so that whole directory and folder structure mimics what individuals, how they set themselves up. And it tends to have a hierarchy. There tends to be kind of this hierarchy where there's departmental or basically facilities or dates or anything like that that seems to help one establish where they place the information, because you're really relying on that hierarchy and your memory of where you stored the information and how you structured and how you set up those files and folders. You're very much dependent on that. And that gets into also the second part of it, which files tend to be a natural means by which we collaborate, by which we share information. So I point you to a share folder someplace, say that's where I last put it, here's the latest version, go grab it from there. That makes the exchange of information all that much more portable and easy for us to work with, since we all share kind of that same understanding about what a file is, and it seems pretty natural. Unlike block storage, we do include a number of attributes with each file. These attributes, which are loosely defined as metadata, cover things like the ownership. In the block world, there's really no sense of who's the owner. You might know who created a volume, but ownership is not so singular. Here we can actually define owners, permissions to them, to the file, whether they have read-write permissions or just exclusively execute permission, things like that to determine. And there may be some other elements that help define and help seclude or open up the use of the files. The common way to access file systems these days, especially in a network environment, would be through SMB, the CIFS protocol, as many of you may know it who've been in the business for a while, as well as NFS. So that the way this gets lined up is usually on the Windows-centric side of the world. People use the SMB protocol. On the Linux and Unix side of the world, they tend to use the NFS. And then there's bridge products that let you access from either one using those native protocol. And this is described as file system. Now, we also have file systems where you're not going over a network, you're actually looking at a file directly on your personal machine, but we're really trying to deal more in this seminar about the broader use where there are multiple collaborators and getting to these network resources.
Yeah, and Eric,
what your thoughts would be on that.
Yeah. I was gonna. Yeah, so sort of relating it back to the previous slide. So what we have here is that file systems really don't exist without underlying block storage in most cases. They really grew up with the block storage behind them. And what they're doing is they're abstracting the block, a single block device up to, when you talk about, network file systems, they could be aggregating together, dozens of different back-end block devices. But again, as Augie's saying here, it presents the hierarchical view of the storage that the humans are familiar with seeing. So think about the hierarchy as we talk now about object, though, that the hierarchy that we're all used to in the file space is a single hierarchy, in that you start at a top level directory and it's got some number of subdirectories, and you follow the tree, whether you draw your trees up or down. In computer science, I draw mine down. You open a folder, you see additional folders, and you keep drilling down deeper into the tree, the single tree hierarchy of the folder or subdirectory organization here. So again, as Augie was saying, you have to decide what your hierarchy is going to be when you lay out the files. The file system doesn't give you natively doesn't tend to give you good ways to search for things. That's generally add-on products to it. But this is the predominant storage that we're familiar with seeing, the familiar paradigm.
And Eric made a point earlier about versioning. In file storage, you're responsible for your versions, and you have to know that they are discrete. So you kept one copy in maybe the version 1 folder, and now you have a version 2, you keep that, and then maybe you have your current folder that you keep things, and maybe that's how you arrange versioning. It does lead to situations where somebody's saying, hey, I've shared this with you previously. What you might have shared with them may have been an earlier version, and they may not be aware that there's a more current revision that they should be working with. So you have to be cognizant of these variations. because they're not intuitive unless maybe the naming, you append to the name things like, oh, that's .v1, that's v2, and always use the latest.
Yeah, and there are some, there have been some versioning file systems out there. VMS had theirs, but it doesn't tend to catch on. I haven't seen it typically used with file systems in practice.
Mine's worked for many years.
And just pointing out that the reason we're calling out all these architectural differences and the differences in usability is because they ultimately impact the workload and workflow, and we'll go into that. But what's under the hood here, how these solutions are architected, affect how they perform for certain uses, for certain workloads in certain environments, and that's why we're setting the foundation for that. So just be aware of that as we move on to object storage. And you are the object expert, Eric, so this is where you jump in.
Okay, thanks, Adrian. So we're talking about, we've come from the block, which is more application interface, to file, which is we think of as both application and human interface. This is where the human can start seeing the organization, having some ability to compartmentalize things. And then sort of the natural evolution of that is up into object storage now, where again, you have applications and humans both interacting with it. Object is the most basic description is that it's a key value store. The key that you would think of from the file system world would be the full path to a file. And unlike coming from the hierarchy of a file system, in the object world, things tend to be very flat. The namespace is flat. The objects don't really have this organizational hierarchy to them. Instead, it relies more on metadata to self-describe the objects that are stored within it. And the reason for that is the metadata being self-descriptive lends itself to searching. So think in terms of the Mac Finder, or the way that Google Docs does things, or even searches, internet searches, is that you don't really start with. You used to browse the internet by going to some sort of directory, and you would click down through what you were interested in looking for. That would be sort of analogous to the hierarchy that we're used to from file systems. And we've changed, and now we just kind of start by searching, and we're basically searching on attributes of the things that we are looking for. We no longer kind of browse a hierarchy to go find them. And so this is where object comes in as these singular representations of files, and it presents itself as a massive pool of data. So you're no longer concerning yourself with necessarily which servers things are kept on. The system is allowed to move things around in the background to optimize or to heal itself from failures that occur in the underlying hardware. And the whole, by having the system be this dynamic manager of the content, that opens up the ability to scale into many petabytes worth of data and billions, without sounding like Carl Sagan, billions of files under management. And it's possible because you're using essentially searching, a searching paradigm to find things. You're asking for things by their descriptions, rather than trying to remember which subdirectory and folders you put stuff into. And it lends itself very directly to user interfaces because object storage tends to be accessed through HTTP style protocols, RESTful protocols. So in the case of Swarm, we support the S3, common S3 protocol. We have a native one that we call SASP, but that tends to be the normal access pattern for it. And so user interfaces, HTML5 rich interfaces, are very naturally built upon that, because that just looks like asynchronous calls to it as it's presenting to you some representation of data behind the scenes.
I think you touched a point on an important point on interfaces. I want to point out. I'm going to ask you, Augie, about the primary differences between block and file, but I did want the viewers to really pay attention to the native interfaces. You see S3 here. We're going to talk about S3 and use cases across the different file types. S3, just having an S3 interface does not make something object storage. It means it has an object interface. There's a big difference because of all the underlying architectural things that are happening behind the scenes. And we'll drive into that in a bit. I just wanted to point that out. Augie, you were going to say something?
Regarding the searches, that may be misconstrued as that the object storage is actually weaving through like a spider of the internals of what's in those objects. It's actually based on the metadata that makes it searchable. So you don't have to actually traverse or sweep the internal constants to determine it. You're getting some hints from these attributes, these self-describing attributes that are attached to the object, and that you can enrich over time. You can enhance the tags, because something might be both an animal and be in the zoo, and that might help you identify and narrow in on it without ever having to peek inside the image, for example, of a giraffe.
Yeah, that's right. And so that metadata can be added at the time that the objects are written, or could be augmented later by humans, or by application processes that are going through and decorating the content with more descriptive information.
Yeah,
Doesn't want to make one other point, Adrian, just is okay. That we're not picking one of these. DataCore offers solutions in all three, in block, file, and object storage. What we're trying to do is highlight some essential characteristics that target why you would use one or the other, help you prescribe which is the better architecture used for a given circumstance. That's really what a big part of the objective for our discussions today.
Yeah, that's right.
Yeah, and that's the perfect segue to the next slide. There's a time and a place for all three of these architectures. There's a time and a place for all of these interfaces, but it really depends on your data. What are your data requirements? That is what ultimately affects your storage selection. So the data type, whether it's structured or unstructured, we just spent some time talking about databases, right? In the traditional world, you had a structured database where you talked to it via SQL. You needed to define everything before you put your data into that database. What Augie and Eric were just talking about is an unstructured database, a NoSQL database, something that you can continually modify and then just run ad hoc queries against, and could be indexed at any time for any type of data. There is a time and a place for both of those. Is the data type random or sequential? From a data access perspective, are these shared systems? What applications are accessing the data? What users and what authority and authentication do they need to access the data, or what is required from the authority and authentication perspective? Is the data chunked or complete? Do you have a whole file, or are you just updating files? Is the data local to the WAN, maybe over LAN, maybe over the internet? What kind of security and access controls are there? What are your performance and latency requirements from an IOPS perspective or a throughput perspective? And of course, how do you want to protect the data? What are the durability levels that you're looking for? Because of course, as the durability levels increase, as business continuity increases, as you make things highly available, that increases the cost. Maybe you don't need to do that. Maybe there are more economical ways where you have some sort of reasonable data durability level set. So you really need to take a look at your data requirements. You need to define them, and that'll help you select the right storage for the use case. And we'll talk about this. I would ask your opinions on this, Augie and Eric, but we're going to talk about these, throughout the next few slides. And this is how data is read and written via protocol. So maybe, Augie, if you want to start with the block and file, Eric, you wrap it up with the object. I think we touched upon a lot of this already.
Yes, I think an important point that was made in the last one, and some of you who might see the word chunked versus complete in the data access area, it's actually very visual what's happening in this slide. With block, you are often just making an update to a very small segment. So in the left picture here, it might be block 12 that you need to update. So a sensor information coming from an IoT device may be just trying to refresh the state of a power grid in that one area, and that's all it's doing. It's just touching that, so it doesn't want to make any other modification, and it's a very lean protocol for that purposes. All of these handshakes that are used to communicate with block storage devices are meant to turn around, send a quick command with a payload, come right back, and get to the next one. So that's back to that high transaction rate. With the file level stuff, we have a very rich set of verbs. These are almost like that human instantiation of what we want to do with a file, and that's what this POSIX compliant part is. And they define the verbs that have grown up over time on how you set the permissions, how you open a file, how you traverse the file to get to different segments of that file. But they tend to be a little bit more constrained than in contrast to object in terms of the scale. We sometimes see use cases where, for compatibility purposes, the S3 protocol is also used to access file, and there's usually some translation that happens, and we'll get into that a little bit more, what the trade-offs are, but you will see those sometimes together, and that creates part of the confusion that we want to help clear up during this webinar. So,
yeah, and then as we move into the object access, unlike the scenario where you may with block, where you may be updating just a very small portion in the middle of your sort of application-defined data structure on block, object is looking at dealing with whole objects at a time. So the typical pattern is that if you're going to write a new object into the system, you provide the entire contents of the object. If you're going to update it with a new version, you would, there are some exceptions, but in general, you're writing the entire thing again to it, so that you have a complete version of the object that is consistent. Meaning that you don't have a partial write in this sort of unknown point in time when, if I read it right now, am I reading the old half in some of the new part that's being written? You don't have that ambiguity, because the object exists as whole consistent versions when you deal with them. And this is where, as Augie was saying, that you can put an S3 protocol on top of file, and generally the application may not know the difference. But when you start to push some of the limits of scaling, that's when you can start to see this translation that goes on really start to, the inefficiency of the translation start to matter. And that's where, the HTTP RESTful protocol sitting on top of object start to come into their own. Now, object also has, it's very common to see these translation gateways that put something that looks like a file interface, a network file interface on top of object. That has some of those same translation representation, problems that you get when you try to put an object interface on top of file, is that you can really push the bounds of that. And we're going to talk about some of the impedance mismatches of that in a moment.
Yeah, we're going to talk about impedance mismatches, and we're going to ask you to define impedance on the next slide, Eric. But we got two questions, and they're both very similar. One of them is, is there an automated process to move files into the object world? And the other one is, can object storage be POSIX compliant? All right, so they're both related, and let's answer both directly. So let's answer the first one. Can you move files from the file-based world to the object world? I'll go ahead and answer that one. The answer is yes. There are file interfaces that can take file system data and move it into the object world. But again, you have to take into consideration what Eric was talking about from a, there is an impedance mismatch, and maybe this is a good time to talk about impedance. I think we could talk about this in the next slide since it covers all this.
Let's back up for 1 second.
Back up.
So can you copy files from, or can you copy files from a file system into object storage? Yes, there's absolutely utilities and tools for that. One of the, part of the question was also, is object the future? Yes, it's the future, but it's not going to completely replace the other two. There are, the part of what we're trying to get across in this webinar is that all of them have places in the world. You're choosing the right tool for the job. There are things that block just cannot be matched for, and it's the reason it still exists. Even with object storage. And there are things that file can do that are very difficult for the object world. Think about a log file where you're, multiple times per second, you're making these small little appends to the file. In the object world, each of those little appends looks like a new version of an object. That's a very difficult use case in the object world to deal with. And so, it's kind of misleading answer to say, is object the future, and say yes to it. It's the future for some application patterns.
And just adding to that, object has been around for quite some time, for about many years, about 15 or more years.
Yeah.
Most people have interacted with it when they deal with cloud storage for many years, email systems many years. I think what you're saying, it isn't so much a future, but it's the way that humans are interacting with data now, today, and for the foreseeable future. So now you interact with the same data in different ways, on your mobile device, on your set-top box, on your laptop, on your desktop. So when you do that, you need a very flexible way to be able to call and view that data, and that is object storage. And I think that's why you're seeing object storage really come up. It's not necessarily, it's been around, it's technology that's been around for a long time, but it's becoming popular now because humans are interacting with data, the same data sets, in very different ways. Is that a fair statement, Eric?
Yeah, it is. And also, I'm an evangelist for objects, so I don't mean to say that the others are dead and leave them in the dust. It's that there are some very good use cases for objects, and there remain very good use cases for file and block.
Yeah. There's also an economic. Just wanted to point out, there's an economic activity that drives some of that, like the move that's being asked about, is in some cases, if there's a lot of file activity, you want to make sure you can get to that and perform the rapid updates and all that. But once those files become less relevant, they become stale, or they can be archived, that may be, in some cases, that's when that move occurs. And some of our solutions, in fact, provide that graceful migration from a file system into object storage, so that the appropriate architecture is applied at the appropriate time to the data.
Absolutely. And that kind of, let's dive into this a little bit. I think we covered some of these points, but what we really wanted to let the viewers know is protocol support does not really guarantee the full value of the underlying storage architecture. That is one of the reasons why DataCore has all three in our storage portfolio, is because there is a time and a place, and there will always continue to be a time and a place for all three architectures. I think both of the questions were actually addressed on this slide. File-based storage that supports object protocols does not deliver the same ease of management, protection, and access at scale. And define scale for the viewers out there, Eric. What are we talking about when we say object scale?
So object scale, again, I'll try to channel my Carl Sagan, but it's the billions and billions of distinct objects under management, as well as many petabytes, dozens and dozens or more of petabytes within an object system, and managed usually by half a person, half a full-time administrator. And so that's scale in the object world, and it can do that because the system itself is doing a lot of those sort of day-to-day management activities, such as dealing with disk drives that go bad, because you will have disk drives that always go bad in the system, and dealing with optimizing where things are stored. So just load balancing, leveling of storage, those kinds of tasks are automated. I'll give Augie a chance, but then I want to come back to the concept of impedance in one of the questions that we have.
Yeah, and Augie, make a quick comment about POSIX compliance. There was a question: is object storage POSIX compliance? I'll go on the record and say, no, object storage is not 100% POSIX compliant.
That's the one I wanted to cover too.
Yeah, right. Any vendor that tells you different is not being truthful with you. So yeah, let's put that on the table. Augie, anything else to add to that point?
No, that was it. Thanks.
Okay, all right. And then so define impedance quickly, Eric, because
let's pop back for one moment. So impede, without getting into the electrical engineering definition of impedance very, very far, it's basically something that resists changes in electrical current, think of it as it resists changes, or it's a sort of a barrier, impedance, if you will, to change. And so the question out there was, can object storage be POSIX compliant? And as an engineer, essentially, sure, you could design a protocol gateway that would be 100% POSIX compliant. But what would you give up by doing that? And this is where the impedance mismatch comes in, is essentially you'd be asking the underlying storage system to behave in ways that completely destroy some of its benefits. So the benefits of scale, the benefits of allowing it to grow up to many, many petabytes and billions of things under management, start to be slowed down severely as you try to bring what is really file semantics, 100% file semantics, into the object world. And the other way applies as well. As you try to bring object semantics 100% into the file space, you start to get similar kinds of challenges there. So the question, could it be? Sure, one could do it, but you'd be destroying then a lot of the capabilities of object by doing that. And that's, so if you need that, you probably need to stay in the file space. So things like object lock or file locking, where you say, I don't want anyone else to touch this while I make a change. That's very hard in a distributed system. That is, its scale comes from the fact that they have independent operators in there that are not absolutely coordinate all of their activities.
And that is a good segue into this, popular use cases by storage type, because sure, you can, but it will greatly impact what you're trying to do with it, right?
Yeah.
So, trying to run home directories on object, maybe a mismatch. This is not meant to be an exhaustive list of use cases. This is just meant to say, hey, These are some popular use cases for these architectures, but you start to see some overlap here. We have databases on the block side and databases on the object side. Why is that? Right? You have media archives on the object side and media production on the file side. Well, why is that? Right? And some people use their file systems for their media archive and for their content archives. You see data lakes for artificial intelligence, machine learning in both object and file. So you can have these use cases, and it really depends on what your requirement is, what your budget is, what you're trying to do with the data. And I think we're going to jump into this in a bit here. There's trade-offs, and that's what you're talking about, Eric. You're talking about the trade-offs.
Yep.
So impedance, electrical engineering, you want to use a natural term, you're kind of swimming upstream, or you're trying to fit around, a square peg in a round hole?
Yep, or vice versa.
Sure, if you have a hammer, you can bang it in there enough and you can get it to fit, but it's, there are some trade-offs. So let's look at this really fast. Augie, do you want to talk about some of the trade-offs from your perspective?
Performance is a really important one. So the performance and latency in particular of how quickly it turns around the transaction, that often is the distinguishing the requirement that drives something towards block, for example. So if it's a small change, has to happen quickly, very little overhead associated with that, that tends to drive it. If it's a more relaxed or the payload's very, very large that you're trying to put in there, maybe a streaming image, that might steer you to further to the right in the diagrams that we've been showing.
And then Eric, you have anything else to add on the trade-offs? You were talking about kind of file locking, collaboration. I guess that would be security and authentication. And you talked about management of resources already and scalability.
Yeah,
we talked about budgets.
Yeah, I think we've covered most of. I think I've covered a lot of the trade-offs. And this just sort of as comments in the slides prior to this. So let's. We certainly have a lot of resources on our website and other videos talking about a lot of these aspects. So I'll defer to those.
Yeah, and I'm going to point out that last bullet point. The requirements also affect whether you use software-defined storage, which we're huge believers of software-defined storage here at DataCore, whether you use appliances, cloud, or hybrid. Now, even in the cloud and hybrid world, someone is managing storage somewhere. So there is storage going on. Cloud and hybrid are really deployment methods in a remote data center being managed by someone else. But you need to take a look at your trade-offs and then select the appropriate deployment method for your requirements. Data protection. So this is kind of a big one. Obviously, you want your data to be protected. Augie, do you want to explain what's going on here in the block and file world?
Yes, in the most common thing that you see as far as data protection in the block world has to do with either redundant arrays of inexpensive disks, the RAID, or some kind of synchronous mirroring or mirroring, just complete copies of that LUN, the logical unit or the volume. And then there are both like metro cluster environments, you often find block systems that are using synchronous mirroring between them. So they're in lockstep, one copy in a different fault domain from another. Replication may be also asynchronous replication for long haul copies, extra data protection outside of the regional disaster area. And then of course you have your traditional snapshots and backups that act on a specific volume. So the unit that's being protected is of smaller scale. It is a fractional piece. On the files, replication backups tend to be the same thing that you do to take care of business. Like I'm making a copy, essentially. I'm making a copy of my file, and underneath that file may have been stored in a block storage device that was mirrored. So I have not only two copies that I made of the file, but the blocks that service and where that data is stored are actually also divided across two different systems. So if one fails, the other one can provide full access. And for object, I'll leave it to Eric.
Yeah, and
So
Eric, remember we have the slide on erasure coding coming up, so we can cover that on the next slide.
So in the object world, the protection is based upon replication and erasure coding, and that's handled in the back end through the system. But the important point to think about here is that it's at these protections are decisions that are made on a per object basis instead of at a per file system or per LUN basis. So you can have both replicated objects and erasure coded objects with different replication values and the different erasure coding schemes in the same system.
Well, I guess one point to make there is this is where the difference is between file system based architectures differ from object based architectures, specifically when you're talking about replication erasure coding. For object systems that are built upon file systems, they have more rigid forms or rigid structures of protection where you cannot mix replicated and erasure coding bits on the same infrastructure. So that's one point. If that is important to you, we do encourage you to ask your vendor if you can mix replicated and erasure coding schemes on the same infrastructure. Then you'll know if there's an actual underlying file system underneath. They say no, you have to set your replicated objects here and your erasure coded objects here. Conceptually, you now know that there's a file system underneath.
Yeah.
So do you want to go over erasure coding really fast?
Sure. It's actually, so erasure coding, some may not know the term, but I'm sure everyone actually has lived with it before because RAID is very familiar with us. We think about RAID 5 or RAID 6, and there's others, but RAID 5 is essentially, you think of it as it's some number of drives plus a parity disk. RAID 6 is some number of drives plus 2 parity drives. And that is erasure coding in its essence, is that you have taken something and split it up into these slices or parts or segments, and then you have equally sized segments that serve as the parity so that you can lose any of the primary data segments or the parity segments, and you can still reconstruct what was lost up until the point that you lose too many of them. And the too many of them means one of these segments more than you have parity segments for. So in an erasure coding 5.2 scheme, that means you can lose up to 2 of anything in this striped or segmented view of the object, and you can recalculate what those 2 lost segments should be. And so you can have the system in the background be busy reconstructing and reprotecting an object when a drive fails. And so choosing the erasure coding scheme essentially allows you to choose your level of durability of the object in the system, and to have different durabilities assigned to the system. How many disk drives or how much overhead are you willing to assign to assuring data protection for objects? That the answer to that's going to be different based upon what is the content. If it's just sort of system logs of an application, that's maybe not as important as billing and financial records in terms of your need for durability.
Yeah, absolutely. And we are seeing erasure coding concepts being used in the block-based world, but we wanted to get a high-level view of the popular ways that data is protected within the storage architectures. Now we jump into use cases. Again, we're going to show you how these architectures flow into popular use cases. Again, this is not meant to be an exhaustive list. This is just meant to give you an example of how the architectural differences and the interfaces are applied for workloads and use cases. So Augie, take this one away.
Yeah, at its most fundamental visualization of a block storage would be the internal drives on a laptop or a PC or a server. If you're dealing with a physical machine, you may have a single, like a SQL Server engine that's basically talking directly to disk. So the SQL Server is the database underneath the billing application that a finance team might be using. And that may be, we generally refer to that as direct attached storage because there's no network. I think that's a distinguishing. So in the next picture directly below it, you now elaborate a storage area network where you have multiple machines accessing a centralized shared resource of block storage. Usually in that case, the central controller shown here has some level of redundancy because it is the single point of failure. So if that SAN controller were to go down, if that SAN array were to go down, all of those machines who are dependent on that block storage would also fail miserably. That would not be a good thing. In the next centerpiece here, we're showing an example of DataCore software being used to build out a hyperconverged infrastructure, where you're essentially combining some of these concepts of the internal storage in a server that is distributed and replicated between multiple nodes for redundancy, yet you have complete access to them. So the virtual machines on the left can get to disk on the right, and similar from the reverse side. And so it creates a pool of resources in that way, but they're all internal to the systems, yet they are accessed over often iSCSI connections or fiber channel between the two clustered. This might be ESX servers, for example, VMware, or Hyper-V in the Microsoft world would be two examples, or KVM. In the third picture, it's a more nuanced view of how block storage is being applied, where we're actually aggregating or pooling different SAN arrays as well as internal storage to make them look like a diverse collection and different tiers of storage that the software makes some decisions about based on the workload. So we have kind of this notion of a virtual disk that's presented up to the application. So the virtual machines are the operating systems up there. And then based on maybe things like access frequency, the software makes a choice. Oh, I think seeing as how this data is being hammered, and it seems to be a very high priority item, I will prefer to keep its blocks on the tier 1 storage. Things that are seldom used gravitate towards the right to the cheaper, higher density storage, might be tier 4. And that pooling is part of the virtualization, block storage virtualization that DataCore brings to the party. That kind of gives you a quick idea about our SAN Symphony product that was shown in the earlier slide.
Then when we talk about file storage.
Yeah, so file storage looks a little bit different. We've kind of hinted at these paths that you need to know. So the path to that engineering uses to get to their files might be the /engineering/ development team in Bulgaria, and a different group, maybe regional in sales, has their own file share somewhere. These appear as discrete file servers. One has to know which machine I'm going to go get that file from, and perhaps you are cordoned off from being able to access another departments unless you're given special permission. So they tend to, there's a kind of a segregation that tends to occur here. In the general case, that segregation also tends to lead to silos of the storage underneath. So engineering's got their bucket of 40 terabytes in this example. Sales has their 60 terabytes. They tend to be more consumers, I guess, in this case. Same thing with the others. One of the things that DataCore brings to the party is the idea of a global file system. And somebody was asking about things like Hadoop, distributed file system. This is where we essentially blend all of these and collect all what appear to be independent shares, like engineering, sales, marketing. They roll up as directories under this global or Uber entry point. And that's what you mount as a user or as an application. From there, you can navigate to any of the other resources without having to know the physical device they sit on. So that's really important. This is really good for collaboration. The other thing that happens here is we're able to collect and aggregate the collective capacity of all those individual silos and turn them to one big pool. And so even if engineering is not consuming as much and sales was actually needed a little bit more capacity, they could draw on that pool based on their current needs and not feel like, well, I've got to add more to my NAS, even though engineering's got space, or the reverse. So this is a way to kind of combine the two concepts of this centralized virtualization view and split it out over multiple sites. And we'll do some other webinars on this to elaborate on.
Yeah, and that's what I'll point out. We have a lot of great information at datacore.com and in the resources section on a lot of these concepts. This was just meant to be a very, very high level overview on all three architectures. And then we segue into object storage use cases. So Eric, do you want to describe what's going on, or you want me to take it?
Why don't you take it here, Adrian?
All right. So from an active archive perspective, you'll see it's a little different than what Augie was showing. You see Swarm in the middle. Swarm is DataCore's object storage solution. It's software defined. You install it on any commodity or x86 server infrastructure, and it creates a massively scalable pool of storage, as we were discussing earlier. You see Swarm just plugs straight into the workflow. You have your HSM or your data mover application on the left. That's plugging into your block or file solution. You see block or file. That can be San Symphony, that could be vFilo, that could be any NAS that you have. And then you have your user and applications on one end, creating the content, storing it on block and file. The data mover HSM moves it to Swarm. Sometimes the block or file solution can write directly to Swarm if it supports the S3 protocol. And then that's where Swarm stores it, protects it. It can be sent to a disaster recovery site, as is shown there on the bottom. And users have direct access to it. It doesn't just have to be a human user. It could be an application. So the application, if it has that unique ID, can just call that data, call the metadata, and display it in a lot of different ways. So even though you don't know it, a lot of the different services that you interact on the internet are architected in this way. Something is creating the content, it's storing it on object storage, and then there's some sort of front-end user interface or application that is calling that data and presenting it to you in a very rapid way over the internet. And there's a lot of the value of object storage built into that workflow. The second use case is video streaming and video on demand. Very similar to what we saw in the active archive use case. You can see that data is being captured, recorded, produced in the block and file world. And then once it is done, once it's ready for consumption, a lot of the times that's when it moves into what's called an archive. And an archive is kind of a misnomer these days. You think of archive and a lot of people's minds go to like a cave somewhere, or maybe that last scene in Indiana Jones, right, where they have all the stuff that they're just throwing in a warehouse. These days, the archive is continuously accessed in a very distributed way for very good reasons, because humans are interacting with data in a lot of different ways. They're interacting on their mobile devices, their iPads, their tablets. They're interacting, even over, telephone systems, calling different audio files. So object storage is a very good way to do that. Here in the video streaming world, since the native interface for object storage is HTTP, you can deliver video directly from the object layer itself. So a lot of the times, object storage is being used to deliver video directly to subscribers. Organizations like Netflix, like Disney, all of the major video on demand services out there are using object storage in one way, shape, or form. And finally, we're getting to the end here. So if you have any questions, you can go ahead and start writing them in the question dialog box. But this is one of the wrap-up slides. How do you determine your storage needs? You really need to detail your workflow. You need to have an understanding of the application and performance requirements, your availability and durability requirements, your accessibility, the network you have to transfer data. A lot of the times that's where you would need to bring storage in-house on-prem, because you don't have consistent bandwidth out to maybe your cloud storage provider, your cloud provider. You need to forecast growth of the capacity and performance needs. We do recommend consulting with trusted advisors. Those are your VARs, your resellers, your SIs. A lot of the times those organizations has spent a lot of time talking to the vendors, understanding the differences, and understanding a lot of what we covered today. And again, we do encourage evaluations and proof of concepts depending on the certain workloads and workflows. Anything to add here, guys?
I think you nailed it.
All right. So for resources and next steps, here's what we recommend. If you do want a more technical deep dive, we were kind of between technical and business, but if you do want a technical deep dive going down into how data is actually addressed via these different architectures on the specific storage media, I do recommend watching SNIA's file versus block versus object webinar. You can just type in SNIA file versus block versus object, and this link will pop up. We do encourage you to go to our events section where we will have all of our upcoming webinars. We also have a library of previously recorded webinars for you. If you do have specific questions and we didn't have time to get to them today, you can ask questions now. We'll see what we can get to. But if we didn't answer your question, or if you want to ask something more direct, please email us at info@datacore.com and we will respond as quickly as we can. And we'll open it up for questions. We're going to go ahead and leave it on this slide. So, just wrapping it up, Augie and Eric, is there anything that we didn't touch upon? Are there any like recommendations you want to give to the audience out there on how to get started? Maybe we'll start with you, Augie.
There's one area that we didn't touch much on, which is the financial aspects of this. Sometimes those trade-offs, we mentioned budget, but they also tend to be just plain old. How much is the per terabyte cost of each of these solutions tends to be higher on the left and decreasing to the right, just because of the nature of the density of how much capacity per unit of storage is kept and the price per terabyte for that. But that is commensurate with the need and the urgency and the rapidity by which you need to get high transaction rates versus something where you're looking more for ease of management. The content is more static on the far right. And so that's intrinsic in that trade-off decision you're making.
And Eric, any comments there, or how to get started, or what we did cover?
Yeah, so yeah, the economics is definitely something that we have other webinars on that, and that's actually a very important distinction for choosing this. It deals with the scale, the scales of deployment and the needs of the application using it.
Yeah, we have a question on, and this is all we have time for, but the unified versus SAN versus DAS storage. Do you want to make a comment on that, Augie? I know we didn't specifically say unified, but how does unified storage fit into the mix here?
Unified tends to be a blend. It's typically an array or a system that has two heads to it. On one side, you can access it as a block storage device. On the other, through another protocol and an access method, you get to the file system. Internally, most of these tend to be either a block storage system that's emulating a file system with a file system head, or the reverse. It's a file system natively, and it exposes blocks of chunks of information for volumes. So it's trying to compress the functionalities into a dual purpose system. And some are adequate to do that, but generally our approach has always been to provide best of breed for the access method and architecture you're looking for.
All right, and then we did get a question on Hadoop earlier. Eric, you kind of touched upon Hadoop.
Yeah, so Hadoop, that kind of goes back to that AI ML case where, is it appropriate? I know Hadoop is used a lot of times with files, tends to put NFS as as sort of I don't want to think about storage to just show me the NFS share where I can go to get at it. And really what's happening there is you're saying Hadoop is a distributed system and you need these independently acting operators to go out to some shared pool of storage, and they need a shared interface to it. One of the reasons to choose file versus object in that case is that you do have these independent operators trying to come through a file interface, and they're sort of needlessly traversing down a directory tree that doesn't need to exist. They don't really need a directory tree, but you're still paying the overhead of traversing through one. Whereas if they came directly to object in that case, they could just, they know the key. The key they have is what looks like a full directory path. And they could use the key to get directly to the content they need to get a hold of. And so that's actually kind of a case where file is often used in that case, but that's just because that's the easiest, most readily available interface that most people have in-house already. Whereas what you see in the bigger sort of, the bigger deployments that you might read about is that people using an object system for AI ML, and the reasoning for that is that you have this concept of a lot of parallel access, and they don't really need the file system hierarchy. That's just sort of a thing that's in the way for them there. What they really know is they know the key to the thing they want, and they need to go process it and then store some result based upon that.
Well, that concludes the webinar. I want to thank everyone for their time, especially the viewers out there. Thank you so much for watching our webinar. Augie, Eric, thank you so much for your time. Again, if you have any questions, please feel free to email us at info@datacore.com. So Augie, Eric, any closing statements before we wrap up here?
Just that it's important to know the application use case, because these all have an important place in the world, file blocker object, and it depends on what's optimal for what you're trying to do.
Absolutely. Augie, any final closing statement?
I'll leave those to you, Adrian.
Yeah, the final closing statement is thank you very much. So have a good morning, afternoon, evening, wherever you are in the world, and thank you so much for staying with us so long today. Thank you.
Bye-bye.